Hi everyone. In this video, we're going to do some revision on the questions for the topic indices, surds and logarithms. After we have learned the tutorial question for these three topics, indices, surds and logarithms. Now I have 41 questions. Okay, I will make them into a separate few videos and discussing about this 40 question. All these 40 questions involve the indices, surds and logs. Look at the first question. Express, this is the surd numbers in the form of A plus B surd C. And question B is a log question. I need to separate them in terms of log X and log Y. And the C is the index question. I need to simplify them and make it into a single index. Hence, then I will find the log H base of 5. Look at the first question. A. To express this in the form of A plus B surd C, I need to rationalize the denominator. Here is the question. You can see that now we have an irrational number at the denominator. So to make it in the form of A plus B surd C, I need to multiply this by its conjugate so that the surd number can be eliminated and the denominator then will become the rational number. So when you multiply the denominator by any of the conjugate on top, meaning that the numerator needs to be multiplied by the same thing. Now we can start to expand it. 2 surd 3 multiplied by 2 surd 3, you got 4 multiplied by 3. Coefficient multiplied by coefficient, you got 4. Surd 3 multiplied by surd 3, you got 3. And the 2 surd 3 multiplied by surd 5, you got a 2 surd 3 surd 5. After that, negative surd 5 multiplied by 2 surd 3, you got a negative 2 surd 3 surd 5 also. So these two terms, obviously, later on you can just get 0. They will cancel off each other. And lastly, you have a negative surd 5 multiplied by surd 5, you got a negative 5. Later on, your denominator obviously can become a rational number where these two surd terms will be eliminated. And now it's a turn to expand the numerator. 2 surd 3, 2 surd 3, you got 4 multiplied by 3. And 2 surd 3 multiplied by 5, surd 5, you got 2 surd 3, surd 5, or you may write 2 surd 15. Surd 5 multiplied by 2 surd 3, another 2 surd 3 surd 5. Surd 5 multiplied by surd 5, you got 5. Now simplify the numerator and denominator. You got 12 over here. 12 plus 5, that will be 17, plus 4 of the surd 15. You always can see this as your A. 2A plus 2A will be 4A. Your A can, surd 3, surd 5 can be written as a surd 15. Over 12 minus 5, that will be 7. Alright, then these two terms cancel off each other. In order to write them in the form of A plus B surd C, we just cannot leave our answer like that. We need to separate them into 17 over 7. That will be the A, plus 4 over 7 will be the B, and the C will be the 15. That will be 17 over 7 plus 4 over 7, surd 15. For the question of the log, I need to separate them in terms of log X and log Y. So here we're going to apply the laws of log. Firstly, look at this operation, division. So I'm going to use take the log surd of X minus log Y cubed. And in order to make them in terms of log X and log Y, I'm going to rewrite this in the form of x power of 1 over 2. And this power of 3, you can just move to the front and make it become the coefficient. You got log y, 3 log y. Then last step is making the 1 over 2 into the coefficient by using the laws of log. So now this expression is actually in terms of log x and log y. For the part C of the first question, h is equals to, now you have an index number where all will be in base of 5. You can all convert in terms of index number base of 5 and then trying to make them into a single index. So firstly, I have my 5 power of 2n minus 1 multiplied by 5 power of n plus 1 and divided by the 25. 25 we always can convert into the 5 power of 2. By using the rules of indices, if your operation is multiply and they're having the same base, the power always can be add up, meaning that I can take the 2n minus 1 add plus n plus 1. And if the operation is division, we can take the power minus the power on top minus the power below, that is minus 2. So now I have make it into the single index, but we need to simplify the power, that is power of 3n, negative 1 plus 1, 0. So I got 3n minus 2. So now you got h equals to 5 power of 3n minus 2. I need to find the log h to the base of 5. Actually, they are asking us to convert this index form into the log form, where when you convert to the log form, the base of the index will become the base of the log. Alright, and this will be h, and the log h to the base of 5 will be equals to the power of the index form, that is our 3n minus 2. For the question 2, given the p equals to surd 2 minus 1, show that p plus 2 over p equals to this surd number. So now we just need to substitute the p as a surd 2 minus 1 into the left hand side and prove them equals to the 3 surd 2 plus 1, that is my right hand side. Alright, so we start from the left hand side first. That is my p plus 2 over p. Substitute the p as a surd 2 minus 1. And now you want to simplify this. Simplify this, you need to rationalize denominator of this second term. Because at the second term, you can see that the denominator is still an irrational number. And what we have at the right hand side is the denominator is 1. So now I'm going to multiply the second term by its conjugate, that is surd 2 plus 1, changing the sign of in the middle here. And on top, you need to multiply by the same thing, that is the conjugate of this surd 2 minus 1. Now we can expand it and trying to simplify. Surd 2 minus 1, just copy it down. It's already nicely present in a simplified form. So you just need to copy down. What we need to do now is expand this. Surd 2 multiplied by surd 2 is 2. So the two terms in the middle will cancel off each other. Let's see. Surd 2 minus surd 2 cancel off each other. Negative 1 multiplied by 1, you have negative 1. On top, that is your numerator. You have a 2 surd 2, just taking the 2 multiplied by surd 2 plus 2 multiplied by 1, that is 2. Simplify further. You have 2 surd 2 plus 2. Because of the denominator is equivalent to 1, so we just can stay with the 2 surd 2 plus 2. And now we are going to combine, or we say collecting the like term. The like term for the surd 2 is 2 surd 2. So you might see the surd 2 as an apple. 1 apple plus 2 apple, that will be 3 apple. And the constant is negative 1 plus 2, that is 1. So we can we can see that the right hand side given is 3 surd 2 plus 1, exactly the same that with what we have here, and we can say that this is equal to right hand side. Then we can say therefore we have shown the statement.